Hello friends, in today's session we are going to talk about correlation, the way in which it can be calculated, and also about the various ways by which the correlational analysis can be carried out. Today we have with us Dr. Ijaz Masih, who's going to talk about the various kinds of correlation, how the correlation exists, and how do we go about it. I request Dr. Ijaz Masih to please continue with the session.
Thank you. Good morning, friends. As you know, today we are going to talk about the correlation. Basically, the word correlation, we all are talking about the relationship. Many things, many variables in this world are related. In fact, we know one thing in relation to other. We can't understand even the light of the day if we are not aware about the darkness. So whether it's a opposite or the similarities, these are the basis of understanding different things. So relationship is extremely important. That's why whenever we talk about the relationship, we understand different things in relation to others. As we know, we are at the moment discussing the coefficient of correlation. When we use the word coefficient, basically we are mainly concerned with a quantitative or a numerical data where the two variables or even sometimes more than two variables are measured in terms of numbers. And we try to find out the relationship between these two. Where it will come? Now, you can see on the screen, we have the definition of a coefficient of correlation. Coefficient of correlation is an index or ratio that can tell us the extent to which or to the degree to which variables are related. So, basically, we are interested to find out three things. The first is whether the two, when we talk about the relationship, for the time being, we will concentrate only on two variables, whether the two variables are correlated or not. So the first basic question is whether there is any relationship between the two variables or not. We are interested to answer this question. The second question is, what's the direction of relationship? Means whether if we increase one variable, there is a corresponding increase in other variables, means the two variables are moving in the same direction, which we call the positive correlationship. Or if we talk about that, if there is increase in one variable, there is corresponding decrease in other variable, we generally call it the negative relationship. So relationship, second answer we want to know from the coefficient of correlation is whether the relationship is in which direction, positive or negative. And the third question is, what's the magnitude of the relation? Means, as you have seen in the definition itself, what is the degree of relationship, what's the extent of relationship? So to answer this, we generally calculate coefficient of correlation. Friends, there are many coefficients of correlation depending upon certain assumptions. As you know, in statistics, we have the two kinds of statistics, one generally known as descriptive statistics, another known as inferential statistics. When we talk about descriptive statistics, basically the descriptive statistics try to describe certain characteristics of a distribution or a group of distribution in a precise manner. So coefficient of correlation itself is descriptive statistics, which can tell you that whether the two variables are related or not. If they are related, whether the relationship is positive or negative, means whether they are two are moving in the same direction. Change of one variable, there is a corresponding change in the same direction, means if one is increasing, whether the second one is also increasing, or whether there is increase of one variable, there is decrease, corresponding decrease in another variable, that is negative relationship. Sometimes the two variables may not be related, that's why no relationship. So we are interested to find out the degree, find out whether the relationship is positive or negative, so direction of relationship. And the third thing we want to, what's the magnitude of relationship. The most popular coefficient of correlation is we have already explained perfect correlationship, no correlationship, and intermediate correlation. When we talk about perfect relationship, means there is, if there is increase in one variable, there is a proportionate increase in another variable, then we call it a perfect relationship. Similarly, if there is increase in one variable and there is corresponding proportionate decrease in another variable, that is known as negative perfect correlationship. So it may be perfect positive or perfect negative, and if there is no pattern, there is increase in one variable, there is no corresponding increase or decrease in another variable, we call the two variables are not correlated. In between no relationship and perfect relationship, there may be various shades of relationship, which we generally call the imperfect correlationship or intermediate correlationship. The most popular coefficient of correlation is generally we called as Pearson product moment coefficient of correlation.
Before we go into product moment correlation, can we also talk about various examples of perfect negative, perfect and positive correlation and no correlation? Would
Definitely.
you be able to describe that also?
Definitely. Where is the next?
No, just say so.
See, when we talk about the positive relationship or negative relationship, when suppose for example there is one very popular variable in education is achievement in any particular subject. We all know that achievement is related with intelligence. If the person is more intelligent, obviously the chance is that he or she will achieve more. So achievement and intelligence are definitely positively related. But whether it's a perfect positive or not, that will decide how much it is contributing. Second important thing may be that some variables, for example, anxiety and performance. Anxiety, higher the anxiety, there is a chance of less poor performance. So the two are negatively related. So there are many kinds of variable when one is positively related with another, and there are many other variables where one is negatively related with other. But whether the two variables are perfectly positively related or perfectly negatively related, that depends upon the situation, that whether this is the only variable which is contributing to that variable. Second, one more important thing which one should be very careful, particularly when we will talk about the Pearson product moment coefficient of correlation. When we talk about the word relationship or even the coefficient of correlationship, generally we found that relationship is itself of two types. One relationship which we called as causal relationship, and another relationship is just an association. Means if when we classify the variable as independent and dependent variable, means that the other variable depends on someone, which depends is generally called as dependent variable, and on which it depends is independent variable, which is not dependent in that context on any other variable. For example, generally achievement depends also on intelligence. So intelligence is independent variable and achievement is dependent variable, and the relationship will be the causal relationship. But sometimes we don't have the relationship as causal relationship. For example, suppose if you measure the achievement height, weight, intelligence of primary school children. You will find that each of the two are related with one another. One set of variable, two variable, one pair of variables are related with other. Can you say that intelligence depends on height, but the relationship is, or height depends on intelligence? Even if the relationship is significant, coefficient of correlationship is quite significant, we cannot say this. So, very simply, that this is just the two are related. So, when we calculate coefficient of correlationship, definitely we cannot say that the two variables are having the causal relationship, but the two variables are merely having a relationship. They are associated, but we don't differentiate that which one is independent or which one is dependent. The second very popular, we will talk about each assumptions of each of these coefficient of correlation just after a few minutes, but first we name. The second kind of variable correlation is generally we called as Spearman rank difference coefficient of correlation. This is another kind of correlation having specific assumptions. The third kind of coefficient of correlation is biserial or point biserial coefficient of correlation. Fourth is tetrachoric coefficient of correlation, and fifth one is phi coefficient of correlation, and the last one is coefficient of contingency. We will talk a bit about all, but first we will talk more about the Pearson product moment coefficient of correlation. Let us think about what are the assumptions on the basis of which this particular coefficient of correlation can be calculated. The very first assumption is that both variables should be continuous. Friends, as you know, that the variables may be of two types, categorical or continuous. Continuous variable means there is no discontinuity, there is no discreteness in between the two consecutive value of that very variable. For example, scores in achievement is a continuous variable. If you talk about score 50 and a score 60, there is a possibility of another score 55. Even if you talk about any other two scores, there is theoretical possibility of another score. But if you talk about, say, sex as a variable, male and female, there is a discontinuity. These are the two categories. We can calculate coefficient of correlation, product moment, Pearson product moment coefficient of correlation only when the two variables are continuous. The second assumption is that we have the two variables, x and y. For example, intelligence and achievement. There are scores of intelligence, there are scores of achievement. Each pair of means one score of intelligence and corresponding scores of achievement should be independent from the other pair of these scores on intelligence and achievement. For example, individual X is individual 1 if he scores 45 in achievement and 110 in intelligence, and individual 2 scores says 65 in achievement and 130 in intelligence. These two pairs should be independent from one another. This is second assumption. And the third assumption is that relationship should be only rectilinear or linear. As you very well know that this relationship, when we talk about the linearity of relationship, it means if we draw the graph of these two variables x and y, for example intelligence and achievement, you will find almost a straight line, and which is, as you know from the coordinate geometry, that this straight line equation is always y is equal to bx plus a, where b and a are the two constant, which you can understand very well. I am not going into that detail. One represent as the height of the y ordinate, and that at the 0 value of x, and the b represent at the slope of the line, which can be represented here as AC by BC, and the line which representing the relationship is already depicted on that graph. So, if the particular coefficient of correlation representing by this straight line, please keep in mind slight variation from this, even then we use coefficient of correlation, but if there is a strong deviation from this equation, we cannot use this particular coefficient of correlation. So, these three basic assumptions, if fulfilled, only then we can calculate coefficient of correlation. Otherwise, we cannot. Now, how can we go for the calculation of these? I have already shown on this particular slide the three different formula which can be used to calculate coefficient of Pearson product moment of coefficient of correlation, which is generally represented by small letter r. So, r is equal to summation of xy. Please keep in mind this xy is, x is a small and y is a small letter, not the capital. As you know from the basic statistics, that generally we represent when small x and small y, that shows the deviations. So, deviations of a score from its own mean, as you will see further that how it can be calculated. The second equation is also where all these x and y are small, which is unfortunately written as capital. And the third formula where everything is capital means we are using the scores. You can see the calculation of this. Suppose x score of different individuals are given. The last row is the aggregate of summation of that every columns. Y is the scores of another variable. We are interested to calculate the coefficient of correlation. So, first column x variable, second column y variable, and these x and y, the third and fourth are small x and small y, which is deviation from their corresponding means. Now, we can calculate x square from x, y square and xy, very clear. By using this, we can calculate the coefficient of correlation by using any of these three formula, depending upon your situation. If you are interested to directly use the scores, you can calculate by using the third formula. If you are using just deviation, taking the deviation from the mean, you can have the second formula. If you have the standard deviations of x and y already given, it's always preferable to use the first formula. Now, the basic issue is, as I said, that there are three basic questions which we would like to answer, whether the two variables are related or not. When you have calculated the coefficient of correlation, you will find that what is the relationship, and that relationship will reflect that the two variables are related or not. Second thing, as I said, that the value of r can be from +1 to -1. In no case it can be more than 1. So, +1 reflect the positive relationship, perfect positive relationship, and -1 reflect the perfect negative relationship. Between +1 to -1, including 0, there may be any value of coefficient of correlation. If it is less than 1 and more than 0, it means the relationship is imperfect. If it is in plus sign, with plus sign means positive number, it reflects that it is positive relationship. If it's a negative number, it reflects the negative relationship. Minus sign means negative relationship. So plus 0.68 means the two x and y are related, and this is the value of coefficient of correlation. If the coefficient of correlation between the two variables is minus 0.48, it means the two variables are negatively related. The third thing we should answer, whether this, how far, whatever the relationship we have calculated in the forms of coefficient of correlationship, whether that particular relationship is statistically significant or not. That is very crucial in a statistic. What generally we want to do? We calculate the coefficient of correlationship or any statistical measure generally by taking the sample. And we are interested to forecast, guess, estimate about the population. Means whether whatever the coefficient of correlation came, that is just by chance or it is the actual relationship. Means if we repeat this exercise, the similar kind of possibility of getting the similar kind of relationship will be there or not. That's why we want to know whether this particular relationship is significant or not. That's why we generally calculate significance of relationship. What we do for manual calculation, if we are interested to calculate about the significance of relationship, first we convert the calculated value of coefficient R into a Z value, Z distribution. You may be familiar with the Z distribution. And in most of the books on statistics, you will find that the table is given for different values of R corresponding value of Z. So we will, whatever we have calculated, we will transform this into Z score. And then we calculate the standard error of Z, which here represented as sigma Z, and the formula is 1 by under root n minus 3. For that purpose, you can calculate the sigma Z. Here I have referred the Garrett's books table. Suppose R is equal to 0.75. If we are interested to find out whether that particular coefficient of correlation is statistically significant or not, we will convert this R from the table and get the value of Z, and fortunately here the value is given as 0.97. Then we have calculated the sigma Z, and then as you know that generally from the normal probability curve, you know that from sigma plus minus 1.96, 95% chances of cases lie between that range, 95% of cases lies between that range, and plus sigma plus minus 2.58, 99% of cases lies between that range. From that very table, we use to find out whether this particular coefficient of correlation is significant or not. So we will calculate Z for example, for the 0.05 level of significance, means whether whatever we say, this possibility of rightness of this is 95%. So we will calculate 0.97 plus minus 1.96 into sigma Z. This star is into. And from this we have calculated that Z will vary from 1.25 to 0.69. Then corresponding value of R we will calculate, and that comes from 0.843 to 0.60. If between this range 0 also comes, it means there is possibility of getting 0 correlation also. Fortunately here the range is only positive. It means this particular coefficient of correlation is statistically significant. But if it comes from plus to minus, means possibility is not there that in all cases the relationship will be significant. This is basically all about the
Dr. Ijaz, before we move on next further to the another coefficient of correlation, what you had already discussed is regarding the significance of R, that is we have to convert the R value into a Z value. Could you please elaborate that why do we have to calculate, what is the need of converting the R value to the Z value?
The simple answer of this is that because Z distribution follow the probability curve, normal probability curve, as you know that Z is a derived score, x minus m divided by sigma, which follows the characteristics of normal probability, and because of this normal probability we want to forecast, which we cannot do directly for the R, that's why we convert it into Z.
And another very important question which comes to the minds of the viewer, that as we have already discussed, that the value of R will always range from +1 to -1. So why is that so? There is a question which always comes to our readers' mind, that why this value of R, that is the coefficient of correlation, will only lie between +1 and -1.
If you will see the general formula for calculating coefficient of correlation, you will find that it is basically a proportion, a square root of a proportion. Okay. So proportion cannot be more than 1. So that's why it cannot be in any case more than 1. Now, depending upon if the relationship is positive, it will be the positive sign. If the relationship is negative, it will be negative. But if it will be more than 1, means contribution. For example, you can illustrate, that slide is not there. For example, suppose the relationship between two variables x and y is, say, 0.25. If you take the square of 0.25, how much?
0.5. 0.5.
So what will happen, that we say that R square represent that what is the common contribution between these two variables, means 50% of the two variables major, if you talk about the two tests and you calculate the R square, because R is square root, that's why we cannot do the R directly, we take the R square, which is generally known as coefficient of determinant. Means how this variable 1 is determined by variable 2. If we are interested to talk about in this way, we can say that 50% is contributed by this variable x through variable y, and the other 50% will be contributed by some other variables. You cannot have in any case more than 100% contribution. That's why it will be always a 1, not more than 1. Now come to the second coefficient of correlation, which is also a very popular coefficient of correlation, but it has certain limitations also, which we generally call the Spearman coefficient of correlation. That's the first is, as it is generally represented by a letter rho. And the first assumption for calculating this is sample should be small. As you know, general assumption in statistics is if the size of the sample is less than 25, we generally call it a small sample. Even in some books it's called, even if it is less than 30, it is called a small sample. So 25 or 30, if it's less than that, we generally talk about it as a small sample. The second assumption is very crucial. If the data is in rank or can be converted into rank form, means first position, second position, third position, fourth position, and so on. Suppose you have given two judges mark the different competitor in a debate competition, and they have ranked them. 3 judges, 2 judges, and first, second, third, fourth, fifth. If we are interested to find out the relationship between the judgment of the two judges, we can calculate very easily the rank difference coefficient of correlation. Formula for calculating rank difference coefficient of correlation is very simple, 1 minus x sigma d square by n into n square minus 1, where d is the difference between the two ranking. Sometimes even the score is not in rank, we can convert into in rank, as you know that there are certain very important assumptions for simple product moment coefficient of correlation also, and that is the two variables should be continuous, and ideally these continuous variables should be represented in the forms of normal distribution. If there is a deviation from this continuity, or if the group is not very large, means even at least not more than 30 or 25, it's not desirable to calculate simple product moment coefficient of correlation. In that case, we prefer to calculate rank difference coefficient of correlation.
There are various examples which can be taken from educational research or from research paralysis in which we can use correlational analysis. Can you just throw a light upon them also?
See, the important thing is perhaps the most popular kind of research is not only in education but in all behavioral and social researches, social science researches, is of correlational research. Perhaps this is the statistics, which I mean the coefficient of correlation, is the most used, most exploited kind of statistics in social behavioral research. If you go into the period of 70s, 80s, you will find that it's the age of the research of what are the factors, what are the variables which are related with achievements. So correlates of achievements, thousands of researches, all variable which are supposed to or theoretically contribute achievement are thoroughly researched during that period. Whether you talk about the psychological variable from personality traits, intelligence, aptitude, attitude, interest, this kind of thing, or even some physiological variables also, there some researchers tried to find out the relationship between, even though researches are carried out about your blood group and the intelligence, your nature of introvert personality, extrovert personality with the achievement, and there are many socio-cultural variables like socio-economic status, attitude towards thing, teachers' contribution, methods of teaching. These all kinds of studies may be put under correlational research. But there are certain misconceptions also attached with the... Where is that?
It is not there.
There are certain misconceptions also attached with the coefficient of correlation when we interpret coefficient of correlation. As I already said to you in the very beginning, that simple product moment coefficient of correlation can never be interpreted as in terms of percentage or in terms of proportion. Why? Because it's not directly the proportion, but it is a square root of that. That's why when we talk about, say, R is equal to 0.5, we cannot say that it's 50% relationship. When you convert it into R square, then you can say something, but R can never be interpreted in that term. Or you cannot say 0.25 is just half correlationship as compared to 0.5. This interpretation is not possible. Second very important factor is that when R is equal to something, you cannot say that this relationship is causal, that which one is independent, which one is dependent. There is no classification, there is no categorization, there is no fixation so far the coefficient of correlation, particularly the product moment coefficient of correlation, is concerned. A third important thing also one should keep in mind, that generally we say that this particular value is very high correlation and this particular value is very low correlation. Please keep in mind, we cannot interpret in absolute term this way also, because as you have seen that coefficient of correlation not only depends upon the value of the two variables x and y, but it also depends upon the size of the sample. So even the low value of coefficient of correlation may be statistically quite significant at higher level of significance if the sample size is very high, too big, too large, and even a moderate coefficient of correlation sometimes may not be statistically significant if the sample size is very small. So with these precautions only we can use these coefficient of correlations.
Dr. Ijaz, as we have seen in research, as you have already talked about, that correlational analysis is used to find out the degree of relationship or extent of relationship. There are certain researches which also try to show the cause and effect relationship. Can correlation be used to find out the cause and effect relationship also?
That's why I said that particularly you cannot talk about when you are just stop after calculating simple product moment coefficient of correlation. But for that purpose we can use some other coefficient of correlation also. Second important thing is, even we are if interested to talk about R square, which is known as coefficient of determinant. Yes. Means what is the contribution of variance by this particular variable to other variable. Then we can interpret with limited context that what is the contribution of that. But theoretically, if we just by saying that the relationship is significant and this value of R is equal to 0.68 or 69 or even 85, and that's why we say that variable 1 depends on variable 2, or the what we call the factor, this is a factor for the other, we cannot say in absolute term if we stop just by calculating simple product moment coefficient of correlation.
And there are various, since the correlation ranges from 0.20 to 0.80, but as we have already discussed, is the number of sample, it influences the size of the sample, it influences the correlation also. Yes. As we have discussed. Can you just elaborate this point once again?
You can very easily calculate the significance of relationship, as I mentioned about the calculation of sigma z. You calculate and find out. You will find, if you find that divided by under root n minus 3, that n will decide what will be the value of sigma z. So if n is more, you will be in a position to say that a smaller value of coefficient of correlation will also matters. But when, so if size of the sample is very small, even the higher value of coefficient of correlation may not be very significant. That's why you will find that in all kinds of, particularly the survey research, when we calculate the coefficient of correlation in almost all correlational study, generally we take a quite large sample, and in that situation even the smaller value of coefficient of correlation is found to be statistically significant. So important thing is whether it's a statistically significant or not. But even then there are certain crude measures which we can talk about, that what is moderate correlation or what is significant correlation, that you can very easily find out. But in absolute term you cannot say. For example, generally we say that 0.8 to 1 is very high correlation, 0.6 to 0.79 is substantial correlation, 0.4 to 0.59 is moderate correlation, 0.2 to 0.39 is slight correlation, 0 to 0.19 is negligible correlation. But these values should be interpreted with cautions. And the basic thing is whether this value is statistical significant or not. Now, the other coefficient of correlation, which we will just talk in a very brief manner, the biserial or point biserial coefficient.
This we will, Dr. Ijaz, we will proceed about these in the another session. But today we have, as we have talked about, what is correlation, how it can be calculated, and how much is it important to find out the significance of the coefficient of correlation. This significance is again, viewers, dependent upon the size of the sample which you are taking. Even if the sample is small, and then the correlation is coming lower, then also it could be significantly significant. So today we have talked about correlation, and with this we come to an end of the program. Thank you.